I'm going to introduce our speaker today. So Mike Keefe is a NASA JPL Solar System Ambassador, and he has been working with us at the Museum for Astronomy Days for many, many years. In fact, is one of our main partners to put on this event. And so he is going to tell us a little bit about why we should explore space. So take it away, Mike.
Thank you, Carrie, very much. I'm going to go ahead and share here. One moment. Okay. Should be sharing the screen. I can get visual or confirmation that we're sharing the right screen.
I see it.
Okay,
it looks
perfect.
Actually, Mike, it's not. I think I have your notes section up.
Okay. There we go. How's that?
Perfect.
All right. Thank you.
Yeah. Oh, you know what? Can you, okay, that's what the bar with the Zoom bar was showing. And so
up here. Yeah. How can I turn that off? Oops. It's still showing up, right?
Yep.
All right. I'm going to stop and redo the share.
Yeah, just, yeah, we should.
Okay. One more time. Okay. There we go. That should be working.
Fantastic. Well. Yep, it looks great.
Okay, perfect. Thank you. So why explore space? And also cover some NASA spin-offs. But I think we have to ask ourselves a big question. Why in the world should we explore space? Why devote those very precious resources that we have when there are so many other things that need our attention and our funding? So what am I talking about? Well, we have some issues here on Earth. We've got to contend with global warming. We have to try and limit our own impact on the environment and slow the those things. There are all kinds of religious conflicts, wars. We've got political polarization across the globe. We have poverty. You know, people really have difficult access to food, water, education, and healthcare. And even in our own country, we have some issues. We've got concerns around government spending. We have educational funding. We have even workforce readiness. Are the kids that we're educating, are they ready to be productive members of the workforce? We have a transportation infrastructure that is definitely old and needs attention. So again, why in the world should we be spending any money going to space? And so I'm going to ask you all to drop a response into the chat session. So from a 5 to 1, 5 being yes, really think we should do space exploration, to a 1 meaning no, we shouldn't. We should devote our money everywhere else. Go ahead and just put your number and what you think we should do. And then I want you to try and remember that number, because after I'm done with the presentation, I want you to tell me what you think after the presentation.
So we're seeing a lot of 5s, some 3s, a few 4s.
Yeah. So I did this presentation once to a 6th grade class, and the teacher started out this conversation, and he was really, really taken aback by a statistic that he put out there, and that is that every 90 minutes, 1 child in the world dies because of either not access to water or not access to clean water. And when you think about that, that basically in the time that we're going to do 2 of these sessions, 1 child would die because they don't have clean water, and that's a very scary number. So when we think about that, we have to put it all in perspective. So we talk about devoting resources, or why even we should explore space, but what does it cost to explore space? So I'm going to show some numbers here about regarding what we spent in 2018. So these were all numbers that I was able to get from various sources. So NASA spent $21 billion in 2018. That's a lot of money. That is a lot of money. And I want you all to, in your mind, think about how much do you think that is of the total amount of money that the US government spends, so our federal budget, what percentage is 21 billion? Is that 1%? Is it 10%? Is it 50% of what the government spends? So keep that in the back of your minds. Well, for Social Security and Medicare, we spent $1.9 trillion in 2018. From a military standpoint, and by the way, in the military spending, there is some space money that's being spent by the Air Force or Space Force. So there is some money there that's spent. Social security or other social programs, $569 billion. This one kills me. Just the interest on our debt alone, $325 billion. Other areas such as transportation, agricultural sorts of expenses, Veterans Administration, and so on, another $651 billion. So the total federal spending in 2018 was $4.1 trillion. NASA was 0.5%. So if federal spending was equal to $1, what we spent on NASA was half of a penny. So that's how much we spent. Now, again, there's a little bit more that's spent in the military, but again, that was what we did for NASA. But what about the other space agencies across the globe? You think of NASA, we've got China's program, the European Space Agency, Russia, etc. If you add up all those space agencies, including NASA, we as a planet, as a society, spent just under $55 billion on space exploration. That's a very big number. So we think about that money. There is another source that basically tries to tease out not only space programs, but also the military. And this is one that we show. Now, in this particular example, they had to drastically reduce the US so it could fit on the page with everyone else. But there you can see this with all the other countries in the world plus us. That's what we spend on space exploration. And of course, in this case, the US is spending the most. So we've got this somewhere between 55 billion and $62 billion. And think about what that money could be done if we wanted to say, no, we want to make sure we have, everybody in the world has clean access to water. What about that kind of money being spent for education? Think of what we could do with that money. And that's a really easy thing to say about, oh, you know what, we need to stop spending money here and allocate it somewhere else. But I want to talk about some other areas of spending. If we think we should reduce spending somewhere, let's think about these things. What about some other areas? Now, I don't know what the makeup is of our folks in the chat, and don't tell us your age range or anything. We're not asking for that, but this might not be very popular with some in the chat. The global market share. So in other words, as an entire planet, what did we spend on video games? And that was $135 billion. We spent more on video games than we spent to explore space. How about beauty products? $532 billion. How about cigarettes? And this is just cigarettes. This is not pipe tobacco or vaping or anything, just cigarettes. $700 billion on that.
We're getting a lot of wows in the chat.
And alcoholic beverages, $1.3 trillion. So when we think about, and people say, oh, we shouldn't be spending money on space. Okay, I understand that. We should devote money from other, to other resources. I would argue that as a society, we need to make better choices all around. And again, think about what smoking does to you or drinking. If we want to reallocate money to important things, there are much better places to pull money from than let's say, space exploration. And why do I say that? So I think there are benefits to exploring space, and we're going to cover some of these. So it might not necessarily make sense right away, but what about, we need to care for the Earth. And how does space exploration do that? Well, this picture was taken from the Apollo 8 spacecraft back in 1968. This is the first time that humans were ever able to take a picture of the Earth from far enough away that the Earth actually fit in the camera lens. And this particular picture is actually thought to have inspired the environmental movements of the late 60s and 70s. And I can tell you, from what NASA does and the missions that it puts up throughout its history, we look at, or NASA looks at, solar monitoring. The sun is what provides all our energy. And it's important to understand the phases of the sun and the impacts to satellites. Imagine if we didn't have satellites out there for GPS. There are lots of, or even communications. So solar monitoring is very, very important to understand what's going on so we don't endanger the satellites that are in orbit. But even other missions that are launched into space, and then instead of looking outwards to space, the satellites are turned in and they're looking at Earth. So over the course of time, NASA has put up 25 missions dedicated only to studying our atmosphere, 25 to understand climate, and then a whole bunch of other ones, understanding continental drift and geodynamics of the Earth and how things are moving, understanding gravity, monitoring hurricanes, monitoring the amount of ice in our polar caps, land and vegetation, oceans, and the list goes on and on and on. So a lot of what our space exploration money goes to is understanding Earth.
So Mike, we have a question from Jonah. Sure. So they want to know, what makes up the significant difference in expenditures in the US compared to other countries, such as Russia?
So in many cases, those numbers, and this is a best guess on my point, best guess, hard to put that out, is that it's not just the big space exploration missions, let's say, launching a probe to Mars, but it's also the keeping up with the space station. And we also put, we put most of the items up into basically on the space station. And it's the fact that we have so many other missions as well. So lots of deep space missions, studying other planets, and so forth. So it really is just the fact that we're doing so much more. It also has to do with the fact that we have a larger economy, so we do have more resources to spend.
That kind of leaves me. So, what is our percentage share of the ISS? Because all of the countries who have astronauts do send them to ISS, correct?
They do. I don't know that number specifically, but that's something I can find out. Okay. But it's definitely the lion's share.
Yep.
And even that, so one other issue, and it's not going to make a huge difference in those numbers, but up until May of this year, we literally were paying Roscosmos, which is the Russian space agency, to take our astronauts to the space station and bring them back down, and also any sorts of supplies. So Russia was the only ticket in town to get to the space station since 2011, when the shuttles, the shuttle fleet was retired. So now having, obviously, we've got the SpaceX program now that was now that can take American astronauts up there. We've got Boeing coming up, and we even have NASA's SLS rocket that's being tested, and that's a Boeing. Actually, predominantly Boeing is the one that's building that. So we will have now other ways to get there. So we won't be necessarily paying, all the expense to Russia to get us up there.
So John wants to know how much Elon Musk is spending on the space program.
That is a very good question, and I don't know the answer to that. A sum of what SpaceX is doing is in essence, NASA is paying SpaceX for that. However, SpaceX is also launching satellites for other people. So it's a bit of a hybrid program. SpaceX does stuff for NASA, but they also communicate with they not communicate, they also launch satellites for other countries and other companies. And say someone, wants to launch another communication satellite, they can now contract through SpaceX instead of having to contract through the more expensive NASA group. And again, that has to do with SpaceX reusable technology.
And then Stacy has a really interesting question. So how does space exploration function in foreign policy in relations between countries? Because we're sharing these resources with countries that we don't necessarily have very good relationships with.
I will talk about that a little bit later in
Okay.
the discussion, and even about the space race.
Okay, awesome.
So some other reasons are just economic. So think about, a lot of people get upset, oh, we're spending so much money on space. We're not actually just taking dollar bills and launching it into space and letting it float out. Every penny that's spent on space exploration is spent here on Earth, and there are jobs that are created. There are 10 NASA centers across the US with more than 17,000 employees. And additionally, there are 100 different companies that are contracted by NASA for services. And just that contracted portion is $14.6 billion of that 21 that they spend is actually money that goes to companies that, maybe we have a family member that works for them. So it's not just money that is only spent on space. It basically is paychecks for people. It's jobs for other folks. So, and the other piece is, even back in the Apollo program, for every $7 that they spent, for every $1 that they spent, there was a return of $7 in terms of technology, in terms of a reinvestment. And that number is closer to $40 for every $1 today. So again, there isn't a return on investment for that. And I'll make kind of the correlation to, let's say, cigarettes. For every dollar that's spent on cigarettes, how much money does society get back? Probably not a lot. In fact, it costs us more because now we have to pay for healthcare and the negative effects of smoking. So again, just there's an economic reason it actually helps us in the future. And I love this quote from President Bush back in 1989. The Apollo program was the best return on investment since Leonardo da Vinci bought himself a sketch pad. So that's a little bit of humor. And then raw materials. Right now, if you think about what happens to our Earth when we're mining, you think of those really dangerous processes. You're basically scarring the Earth, and it's also difficult. Now, it's estimated that what the precious metals that are in the asteroid belt are worth $700 quintillion. That amounts to $100 billion for each person on Earth. Now, would we ever be able to mine it all? Probably not. But there is an amazing amount of resources that we could actually use from space, and that we wouldn't have to incur the environmental impact of that on Earth. So there's a real economic advantage of doing that in space. For example, the moon. Sorry, go ahead.
I was going to ask a question. So we have an environmental impact of mining these things on Earth. What about the environmental impact out in space?
So that's a good question. Space is already really irradiated, and it's not healthy. To the best of our knowledge, we don't know of any life forms that live in space. But more than anything, the fact that if you could mine things in a microgravity environment, you wouldn't have to, in other words, you wouldn't have to burn as much fuel. And in that case, you're probably going to use solar energy rather than some sort of combustible fuel. So even if there was an environmental impact, it really wouldn't be the same as it is here on Earth. Now, again, there's always a benefit and a cost here. So if you start mining all the asteroids and you take all that material away, what's that going to cause? I mean, what happens if you start breaking up asteroids and instead of something that you can travel through, now you create a complete debris field that you can't pass through? Yes, I mean, there's always going to be a cost benefit analysis that has to be done. But to the other point is the moon is thought to be a source, an amazing source of helium-3, and that is very rare here on Earth. It's used in MRIs, and it's also theorized that could be a key component in actually having nuclear fusion, which is what the sun does to produce energy, versus today, fusion. What we do today is nuclear fission, which is when you explode an atom, and that causes, in essence, nuclear waste. If we could do fusion, there really is no waste. Other reasons to go into space exploration are the benefits that we can actually get to our own bodies in terms of healthcare. So this is just a very small list of the innovations that they've been uncovered through the use of the International Space Station. So they're looking at methods to deliver cancer-fighting medication directly into tumors. So stuff that doesn't have to go into your bloodstream, doesn't have to hurt the rest of the body as you try and fight the tumors. This is one that's really big for me because my day job, I work for a pharmaceutical company. And when you think about vaccines and these pathogens, especially, this is very, very important today that we're in the middle of the COVID-19 pandemic. Being able to study these pathogens in microgravity allows scientists to really understand exactly where the weaknesses are in that pathogen. So they're able to get a better understanding of, oh, how do we fight this, this pathogen, this virus? And those are things that you really can't do in 1G of gravity here on Earth. There is a lot of science and investigation being done on preventing bone loss. This is a major problem for astronauts. For every month that an astronaut is in microgravity, you can lose 1 to 2% of your basically your bone density. So things that we're going to find out through experimentation and research on the ISS will actually help us as we get older to help with osteoporosis. Now, this is another one. I put this slide together a couple years ago, and never heard of this concept called telemedicine. But now it's actually so commonplace to have the conversation via a Zoom meeting with your doctor. But this has been going on in this ISS for quite some time, and even there, they have remote access to instruments. So the patient and the instrument are somewhere, and the doctor is far, far away. So that's a concept that's being perfected, used and continuously being perfected in the IIS. Also, this is a device to make sure, and also implemented are devices to get very, very rapid medical readings from, again, over distances. So imagine now, more and more so, you've got patients that can leave the hospital and still get all that monitoring done. Again, started with the ISS and being perfected. Again, artificial limbs, understanding robotics and materials development, making sure you're using the best materials that are lightweight. So lightweight, you gotta be easy to get up to space, but also lightweight if someone needs an artificial limb. And devices that enable medication management, as well as software that measures behavioral alertness. And it's funny, you even see some of this software now coming into vehicles that we're driving today. It can tell, certain vehicles can tell, are your eyes watching the road, your hands on the steering wheel. And this is all technology that has been spun off from NASA. So we talked also about international cooperation and also some treaties. And to me, this is huge. So when we think about the space race, it was a race to prove what system of government was better, and that was between the Soviet Union and the United States. And this was, a lot of money was spent during that time. But when you think about it, that was a war that happened, but in that war there were no bullets fired. So imagine if we had done had that as an actual war, that would not have been good. With the two supreme nuclear powers in the world, and even the International Space Station, it forges strong diplomatic ties between nations, and things have not been great between Russia and the U.S. Yet, from the space exploration side, from the Roscosmos and NASA side, though they're partners, they're collaborators. They work together despite the politicians having their own disagreements. But as agencies, they've worked very well. Our own NASA astronauts have trained at Roscosmos and vice versa. So there is cooperation. And again, it's beyond just the politics. It's really the two nations working together. Another big point about continuing to explore space, it's going to get harder and harder and harder the further and further out we go. And the ability to spread the cost across countries is important, because even getting to Mars, the possibility of one country doing it alone is going to be a lot lower than if we work collectively together. And in one of these pictures, just a diagram, you can see all the different operation management stations that are used for the IIS. So no matter what, there's always a group that's available. So while someone in the North America is sleeping, we've got colleagues on the other side of the world that can help with those operations. And then here are just a few logos of the different space agencies. It was asked about certain, how the cooperation works, and there's a great, I don't have the link with me, but is a great site on NASA that talks about all the different international relationships or international agreements that have been put forth. And it just goes through the whole list. I can't remember how far back it goes, but I did remember seeing once where they had an official agreement between NASA and Roscosmos back in the early 70s for the Apollo-Soyuz mission. So there are agreements in place on what is expected of each of the parties. Another one, and I think I may have seen one in the chat, is just, hey, we should explore because we're curious. And I love this quote from Neil deGrasse Tyson. If anyone doesn't know who he is, he's a really famous astronomer, and he actually is the head of the planetarium in New York City. But I love this quote. I could stand in front of 8th graders and say, who wants to be an aerospace engineer so you can design an airplane 20% more efficient, fuel efficient than the one your parents flew? Versus, what if you said, hey, who wants to be an aerospace engineer and design the airplane that will first navigate the rarefied atmosphere of Mars? If you ask it in the second way, you're going to get the best students in the class. But we are curious, creatures by nature. Ever since we left Africa 200 and some odd thousand years ago, we've explored every corner of the Earth. Exploration really is in our DNA. And we can go back in history and just name a few people: Marco Polo, Christopher Columbus, Magellan, Lewis and Clark, Sir Ernest Shackleton, Amelia Earhart, Jacques Cousteau. I mean, the name goes on and on and on. And these are heroes. So, deep down inside, we want to explore. I mean, who has ever, and it's the next piece here, but who's not hiked up to the top of a hill just to say, hey, look how far I can see? And the Apollo and Gemini missions and the Mercury missions, they inspired a whole generation of engineers and scientists back in the 60s and 70s. But also, how about our own survival? And I think I saw it posted a couple times in the chat. All of our baskets, I mean, all of our eggs are in one single basket, and that's the Earth. Anything happens to the Earth, and that's it. That's game over for humans. This graph here shows the number of families, and we think about that in terms of the classification of all the different types of animals. And I don't remember them off the top of my head, but you've got families and phylum and species and that sort of thing. But so this shows families and the number of reductions throughout the course of our geologic past. And you just see these major extinction events. They happen. It's not a question of if it will happen to the Earth again. It's a question of when will it happen. So is it another ice age? Is it a huge asteroid strike that causes mass extinction? We don't know. But it'd be a whole lot better if we had other places in our solar system or even beyond our solar system that where humans were. So in case something horrible like this happens and we can't stop it, we as a species will continue to survive. And then the good part. So I talked about some of those spin-offs. Hey, we'll actually get, we invest $1, you'll eventually get more money out. So these are some of the top 10 spin-offs. At least I consider them my top 10. So, and this was really key, especially around the Apollo era. So you had the Apollo guidance computer. So this is the one that was in the capsule, the space capsule, and helped actually guide the astronauts down to the moon. At that point in time, computers that could do that took up rooms and rooms to do it. NASA and the Apollo program was able to get it down to something that weighed 70 pounds. Well, now our watches could do this, but back then that was a huge reduction. And that was one thing that the US always focused on versus other, especially the Soviet program. We were constantly focused on making things smaller and lightweight. As a result of the Apollo 1 fire, which happened, I can't remember, but yesterday, the 27th, was actually the anniversary of that. I think it was 67, if I'm not mistaken, 1967. But unfortunately, or maybe it was 66, 3 astronauts died in a fire in the capsule. But as a result of that, NASA looked into all sorts of fabrics that were fire resistant. And this is called beta cloth, and it is widely used across the world today. And even though NASA helped create it, they brought in companies like DuPont and Owens Corning to come in and actually develop this technology. Now, I think everyone might have something that looks like this, a phone. It's got a camera in here. These cameras now, these nice, very thin cameras that are very good quality, are possible because of what NASA has done. And that is specifically with the CMOS image sensor. CMOS sensors are much smaller and thinner and lighter than their corresponding CCD chips as well. So that is another piece of technology that we can thank NASA for. Memory foam. It was originally used for cushioning in the seats for test pilots. How about sunglasses? Anyone have scratch-resistant either lenses or sunglasses? Well, that is based on technology used on astronauts' helmets and visors to make them scratch-resistant. Because the last thing you need is something scratching your visor. And if you're in full sunlight, that can cause blindness if any sunlight comes through, if you're in outer space. Our atmosphere here on Earth helps shield us from a lot of that. How about even cordless tools? Now, cordless tools had just started to come around back in the early 60s. So NASA did not invent them, but they worked with Black & Decker to really get it to the point where the batteries were better, the torque was better. So they helped develop that technology, and then eventually Black & Decker went with it, and they just took that technology and applied it to their retail business. But if you think about it, when we went to the moon, you couldn't just take your drill, and this is a picture of a drill that you drill into the lunar surface. You couldn't just go plug it into an outlet on the spacecraft or even an outlet on the moon. There was no energy. You had to bring the batteries, and you had to make it portable, and you had to make it light enough that they could put it into space. Other great spin-offs. So GPS, if anyone has ever driven in a car, use GPS on their phone. I know I like to use my iPhone because I'm always leaving my earbuds or AirBuds or whatever called AirPods somewhere, but that's GPS technology. JPL used that technology to reduce the accuracy of GPS from 15 meters to 5 centimeters, and that is big, especially when you're navigating or trying to find your AirPods. Water purification. This NASA just absolutely had to get this right for the astronauts because you have to clean your water. You can't just keep shipping bottles and bottles and bottles of it. And they've taken that to extremes. But again, that technology is then given to the public. This is an example in Turkey where they're using, it's NASA technology, and they're helping farmers actually get cleaner water. The artificial pump is actually a miniaturized version of the shuttle fuel pump that was used in the engines. When you think about all the fluid dynamics that they had to get right to get the right amount of fuel, and again, it's fuel that's mixed. So you've got an oxidizer, which is liquid oxygen, and then you always have some kind of propeller or incendiary. So it could be rocket fuel, it could be liquid helium, or all sorts of things, or liquid hydrogen. But that fluid dynamics, all of that has helped making sure we can get artificial hearts that work incredibly well. And even something silly as what we call a voltage controller. So imagine if you're going up an escalator, an elevator, and if it's a full elevator or you have lots of people on the escalator, what happens if it's slowed down? Now, I don't know if anyone's been at a mall lately, but if you remember way back when, and you're in an elevator or an escalator, they don't slow down because a lot of people are on it. And that's what a voltage controller does. And that was used, again, and definitely perfected with NASA to make sure that you got a constant speed out of the motors, regardless of the load or regardless of the weight. So that is technology that has been absolutely turned over and developed through NASA and then sent out to industries. So with that, those are the spin-offs and the kind of the technologies, and also my reasons. So I had originally asked at the very beginning of the talk, I said, give me a 1 or a 5 as to what you thought about space exploration. Is it worth it? Is it not worth it? And feel free to now jump, put a number in the chat session if I've been able to change your mind. So looks like
I got some 5s.
Even got an 80. That's good. That's good. I like 80.
Nice. Awesome. Well, do you have time for a couple questions?
Absolutely. Absolutely.
All right.
In fact, that is question time.
Awesome. Okay. So Nancy wants to know if any members from NASA have ever seen hints of aliens.
That's a good question. And
tell her we were having a talk on SETI on Saturday, and then you're doing another talk on the Fermi paradox. So
exactly. I will say that there have absolutely been sightings of objects or things that cannot be explained. So there are a ton of different possible explanations. Just one has not been validated. Let's put it that way. So outright, not necessarily a confirmed sighting. But personally, I believe that there is always a possibility.
Awesome. And then she also asked if it's possible to grow a plant on some planet in space.
So they do grow plants in space, and that they do that at the IIS. Now, we have never set foot on another planet per se, other than Earth. We've been to the moon. 12 people have walked on the moon. The moon would not support plant life. There's not enough water, then there's no oxygen, or actually in the plant's case, there's no carbon dioxide that they could breathe in, so plants would die. You'd have to make sure that, and it'd be a tough experiment because one, you don't necessarily want to introduce a foreign body like a plant to another planet without understanding the full impact. So would planting something, let's say, a radish on Mars, what would that do to Mars if there's anything living on Mars? So it's possible, but you'd have to make sure all the right conditions are there, and you don't want to contaminate any other environment.
Awesome. So Anish has a great question. I want to know the answer to this one too. Do you think there's a chemical compound in space that can take the place of plastic or paper but not have the negative effects?
That would be amazing. That would absolutely be amazing. And unfortunately, I am not a materials scientist, so I'm not qualified to make that answer. Could it be possible? Absolutely. I think it's something that, and that's the sort of thing where it would be great to understand. So more than that, if you could make things in outer space, especially if it's going to be used for outer space, it'd be much better to keep stuff out there instead of having to, in essence, spend the money to launch heavy things or up to the people in space. So again, could we get water off the moon? Could we develop our own rocket fuel from the materials that are there on the moon instead of having to try and lift that all from Earth? So yeah, that would be amazing.
And so John wants to know, do you think that space exploration is about survival?
Ultimately, yes, absolutely. If we don't broaden our footprint as a species, eventually the Earth will no longer be able to either support the number of humans we have, or we will destroy the world, or something is going to come and big asteroid's going to strike. So that ultimately, yes, it's about survival.
Awesome. And Jacob wants to know how much helium is on the moon.
How much helium-3? I don't know that. I think at the moment they're just estimates, but the amount would be enormous because it's something that is created freely by the sun and pushed through the solar winds. Unfortunately, it doesn't get here on Earth because of our atmosphere. But on a place like the moon, it's free reign.
Very cool. And then John wants to know what the average age of astronauts is. And we just had a talk this morning. The supercluster was presenting the astronaut database, and I highly recommend, John, that you go check that out. That has every database of every astronaut and every living thing that has ever gone to space. So maybe one of our other moderators can put the link to that. So we're going to get that video posted in just a few minutes so that you can watch that program. Awesome. So I don't know, did you want to take a stab at average age, Mike?
Oh, I would not know. My personal sense is that it's gotten older over time. So you had a lot of young, especially in the Mercury, Gemini, and Apollo years, you had test pilots, younger test pilots. Now you see older, kind of more established scientists. So folks with multiple PhDs running experiments and that sort of thing. So that's my guess, but I would not be able to answer that with a fact.
Yeah.
Do you know,
in
Carrie?
that astronaut database, you can figure that out.
Okay. Yeah.
Okay, Jennifer wants to know. So they watched a movie called The Martian where
Mhm.
JPL is in the film a lot. And have you seen it and how realistic is it?
So I am only a volunteer through NASA. And we're called Solar System Ambassadors, and we get trained on a lot of the missions. So I've never been to JPL, but what I have heard about that movie is that it was actually pretty spot on in many, many cases. So um, the one part where it was probably a little bit off was in the growing of the potatoes. And I don't know the exact science about it, but there's something in the soil in Mars that you would have to extract, because otherwise it would be very dangerous or poisonous or something to any kind of plant life. So I think if I remember reading an article way back when, but I think that was kind of the part that was off the most. But for the most part, everything else was pretty well within the parameters of expected or acceptable you know, tweaks. Definitely not like Armageddon, which is completely impossible.
Good to know. So Carol wants to know, what do you consider the most important aspect of space exploration?
So that's a really interesting question, and this is just me personally. Um, I think the most important thing now to determine, and that's the way I'll answer this question, is really how the human body deals with different levels of gravity. So today, we know our bodies love 1G. We're here on Earth, it's 1G of gravity that keeps us here. Our bodies are designed for it. We live many, many years. Everything's great. With our other data point we have is microgravity around, basically in space. We haven't spent enough time on the moon to really even understand the 1/6 gravity that's there. So we have two data points. Our bodies do not like um, microgravity. There are circulation problems. There's problems that affect our eyes. We have basically, our bones lose density. Our muscles atrophy. And even though we try to exercise and do all those things, um, our bodies do not do well. And if you ever look at um, any of the returning astronauts coming down, especially from long 6-month missions, and they used to land uh, basically in Russia, because again, they were bringing us back down. They would literally pull the astronauts out and they would put them in chairs and they would carry them in chairs. They weren't even walking. And that was because after 6 months, they're very worried about even being able to walk. Your bones have in essence um, lost a lot of the density. You could break a bone if you fell just off of a simple ladder or something like that. So I think that we need to get out into space, do real studies on what microgravity means, because um, does our body react if just enough gravity is fine, so maybe 1/6 gravity on the moon and everything is perfect for us? What happens when we get to the moon at to Mars, 1/3 of the gravity, and it takes a long time to get there? So overcoming the 9 months of microgravity being there, and then a year plus being on Earth, or sorry, on Mars, and then the trip back, it might have to be a one-way trip because people would not be able to reacclimate to Earth. So we need to study all those things and understand how our body reacts to it before we start sending people and then, oh, sorry, yeah, your trip was a one-way trip to Mars, can't come back. So that to me is the most important piece of space exploration today, how our bodies will be able to adapt.
It's really cool. So Adrielle wants to know when, and I'm going to add if, it's ever, when do you think humans will explore outside of the solar system?
Oh, well, technically we are. So we have probes that are finally outside of our solar system. Um, Unfortunately, they're not in any other solar system. Um, I hope it's a when and not an if, but there are major engineering challenges to overcome. Again, just the gravity alone, and how do you make a self-sustaining ship that will be able to travel for decades? Because that's what it would take to get to, even at, kind of incredible speeds that we can't even get to today. It would still take decades to get to the next system. If we could travel at light speed, which you can't, you can either go close to the speed of light, or we've got to figure out ways to, kind of bend space and time to get somewhere. But if you could travel at the speed of light, the nearest system is, 3 or 4 light years away. So again, how would you survive, years in microgravity? So I hope it's a when and not an if.
All right. So Stacy has a question. Not everyone is cut out to be an astronaut. So what are some examples of ground jobs for other people that would like to be involved with NASA?
Oh my gosh, the list is incredibly long.
Maybe maybe a JPL SSA?
So yes, so educators, believe it or not, there are educators within NASA. In fact, the reason why I am an SSA and why NASA uses people like me is because that is part of NASA's charter to educate the public on what they're doing. So they could either send their own scientists and astronauts and take away from missions that they're working on, or they educate us and we in turn educate the public. So again, within even just the educational group, there are a lot of folks involved. And I'm not going to go into the technical ones first, but they do a lot of PR work. You see a lot of people out there doing official spokes people for NASA, and they're there doing all the television shows, shots, that sort of thing. There's a lot of administrative work that goes on. But then even beyond some of those, kind of less scientific areas, you've got all kinds of engineers. So you need aerospace engineers to design spacecraft. You need material science engineers to work on, those cutting edge, new materials that will be lighter and stronger to go up into space. You've got electrical engineers and computer scientists that put all this stuff together. And then you're going to have a host of manufacturing type of opportunities. So, and then now start talking about the missions that NASA sends probes on. You need, geologists to understand when you're looking at some of the moons of our solar system, potentially even biologists when we start to find maybe evidences of fossilized little microbes on Mars. I hope that happens one day. So really all of the sciences lend themselves to possible jobs that you have. And of course, you can say astronaut, but most astronauts have a specialty in another field. So either they were an aerospace engineer, or they're a chemist or something along those lines, but they have those advanced degrees and they get sent to a mission or up the IS on a specific mission to help conduct experiments in outer space.
Well, I think, we are out of time. We don't have time for more questions, but if folks do have more questions, or if we didn't get to your question today, then I'm going to put my email in the chat, and you can email me and I can reach out to Mike for you.
Absolutely.
Sorry, it takes me, I can't talk and type. So I've just put my email in there. So send me an email if you want your question answered, and I'm going to go ahead and share my screen again. And just because I want to show you our amazing t-shirts and hoodies. So if you want a memento of Astronomy Days, virtual Astronomy Days this year, you can go to the museum store and get a t-shirt or a hoodie. I want to thank you, Mike, so much for not only this amazing program today, but for all your work with Astronomy Days over the years.
My pleasure.
Mike's going to be speaking again. So go to our program page to check out the rest of the programs that we have going on. So it's only Thursday. We have all day programming, Friday, Saturday, and Sunday, and then a couple more programs this afternoon too. So lots more Astronomy Days out there. Thank you to Space Grant. NC Space Grant is our sponsor for Astronomy Days. Thank you so much to them. And thank you to our museum, our friends of the museum, our members who help us every day to keep our programming going. So everyone, thank you so much. Have a great afternoon, and I hope we'll see you again for another program.